disturbance from my side?
No, sir.
All right, so 35 have joined. Still the people are joining. But anyways, let's start. Okay, so let's recall the things we have discussed in the last lecture. We have discussed, we have started with the definition of linear differential equation, right? So a differential equation which contains differential coefficients and the dependent variable in the first degree and does not involve the product of derivative with another derivative or with a dependent variable and in which the coefficients are constants, right? So that is called the linear differential equation. The general form of linear differential equation of nth order we have seen as a naught nth order derivative of y with respect to x plus a1 n minus 1th order derivative of y with respect to x plus and so on a n minus 1 dy by dx plus a n y equal to f of x, where these a naught, a1, a2, a n are all constants, right? For example, this differential equation we have seen. So we are going to solve such linear differential equations of given order. So the solution for the solution, the first step is we substitute the differential operator to be capital D there. Let me check it out. Anyone is waiting? Okay. See, if you're joining with your personal IDs, then that will ask for the permission for joining. Okay. If you join with the PCCR ID, it will not ask. So the first step towards the solution is we substitute the differential operator to be capital D there. On substitution, we will get the equation of this form. Some function of d into y, that is dependent variable, is equal to function of independent variable on the right hand side, isn't it? So we call that function of d as a phi of d. So the reduced standard form of linear differential equation is phi of d into y equal to function of x, right? Where phi of d is a polynomial in d, we can say polynomial. I hope everyone knows about the polynomial. Polynomial कौन होता है जिसके powers of variable are integers, in fact positive integers, isn't it? So that is why we call this phi of d as a polynomial where the variable is capital D. So oh, sorry, I forgot to share my screen. Thank you. I'm sorry. Thanks, Aditi. Actually, I forgot to share my screen. Okay, so we are discussing the solution of nth order linear differential equation. This is the nth order linear differential equation where we substitute the derivative operator to be capital D there. On substitution, we will get the equation of this form, uh, where this is of this form phi of d into y is equal to f of x, where phi of d is a polynomial in D, right? So this is the reduced standard form of linear differential equation. And as I told you that the solution of linear differential equation is the value of dependent variable involved in the equation in terms of independent variable. So here we have considered dependent variable to be y and independent variable to be x. Therefore, its solution will be the value of y in terms of x. And that solution we call as a general solution or complete solution, right? So general solution or the complete solution will be of this form where y equal to cf plus pi. Both cf and pi are the functions of x or the functions of independent variable. So our job is to find these cf and pi separately, and then by combining them in this form y equal to cf plus pi, we will get the required general solution. ठीक है, so we have started with the complementary function. Complementary function क्या होता है? Complementary function is the solution of homogeneous differential equation. So what is mean by homogeneous differential equation? Homogeneous differential equation is the given differential equation with right hand side to be 0. See, we have seen the homogeneous differential equation definition in M2. That is also the correct one. But here in linear differential equation, the homogeneous differential equation means the right hand side to be 0 there. Okay, so we consider the right hand side to be 0 of the given differential equation, and that is called a homogeneous differential equation. So we solve this, and its solution is nothing but the complementary function of the given differential equation. Okay? So to solve towards the solution, we consider its auxiliary equation. Auxiliary equation means we equate that polynomial to 0. That is phi of d equal to 0. So we solve this equation, auxiliary equation for d. And as we know that we have started with the nth order linear differential equation. So phi of d is a polynomial of degree n. Right? So as it is of degree n, it will have n roots. Suppose those n roots are of this form m1, m2, mn are n roots of auxiliary equation, then the complementary function formula is this. And we have seen the logic behind this formula, the proof behind this formula by considering the linear differential equation of first order first degree. Okay? And its solution, that is y into I, that is integrating factor, is equal to integration of q into I plus c. Right? So by obtaining the solution corresponding to the linear differential equation of first order first degree, we get its solution of this form y equal to c e to the power mx. So as if you look at this factored form of homogeneous differential equation, where each factor is of the form d minus m1, d minus m2, and so on, d minus mn. So each root will satisfy the whole equation. If we substitute, suppose d equal to m1, then we will get 0 directly onto the left hand side. Similarly for m2, we will get 0. Similarly for mn, we will get 0. So all these roots satisfy the differential equation. Therefore, with respect to each root, we will get the solution of this form. So corresponding to m1, we will get the solution of the form c1 e to the power m1x. So we call it as a y1. Similarly, corresponding to m2, the solution is c2 e to the power m2x. We call it as a y2. And so on, corresponding to m2, we will get the solution of this form cn e to the power mnx. We call it as a yn. And as I said, if y1, y2, yn are the solutions, their sum is also a solution. Or uh, in general, its linear combination is also a solution. So we call that linear combination as a capital Y. So y equal to y1, y2, yn is also a solution of homogeneous differential equation. So the solution of homogeneous differential equation is nothing but the complementary function. So Cf is equal to C1 e to the power m1x plus C2 e to the power m2x plus and so on. So this is what the logic behind the formula of complementary function. Is this clear to everyone? Everyone, put your
Yes,
replies in the
sir.
chat box, please. Everyone, if any doubt, any query related to the complementary function, you can ask. Hmm? Everyone, drop your replies in chat box. Let me see how many of you are really attending the lecture. Hmm? Yes, very good. Okay. Okay, thank you, everyone. So now the point is whether this formula for the complementary function is in general for all roots, because we all know that there are nature of some roots, like roots can be real, roots can be complex, isn't it? And in that also, roots can be real distinct or roots can be real equal, isn't? Similarly, the roots can be complex and distinct, and roots can be complex repeated, right? So based on that, we have the four formulas of complementary function. Let me show you. Okay. So depending upon the nature of roots, we have the four formulas for the complementary function. That formula is the general formula we have discussed. This is the general formula. Someone is waiting there. Okay. So the depending upon I hope this is visible. Depending upon nature of roots, there are different forms of complementary function. Okay? So the first nature is, suppose if the roots are real and distinct. That means if the roots are real and unequal, hmm, then what is the formula? So suppose if m1, m2, and so on mn are real and distinct root of auxiliary equation. What is the auxiliary equation? Phi of d equal to 0. So if m1, m2, mn are the real and distinct root of this auxiliary equation, then the formula for complementary function is then CF is equal to complementary function is equal to the same formula, C1 e to the power m1x plus C2 e to the power m2x plus and so on Cn e to the power mnx. Okay? So I hope there is no problem with this formula now. We have discussed the logic behind the formula also. If you want one example, so let us have a simple example for this. Suppose if we want to ask to solve this differential equation, for example, solve which is already in capital D form, suppose d square plus 2d plus 5 times y. Okay, so the just a minute. It will gives the different roots. Someone is waiting there. Swapnil. Okay. Uh, the equation is d square, suppose, plus 3d plus 2 times y is equal to 0, suppose. So it is already a homogeneous differential equation, right? So its solution is the complementary function. So let us solve this. So for the solution, what we do, we consider the auxiliary equation, that is d square plus 3d plus 2 equal to 0. And so what are the roots of this equation? D equal to, hmm? What are the roots? By splitting middle term or by factorization method only, you'll get the roots easily.
-1, -2.
Exactly. The roots are -1 and -2 because we know to find the root, we find the two numbers whose multiplication is plus 2 and whose addition is plus 3. So 2 and 1 are the numbers whose multiplication is 2 and addition is 3. So with the help of 2 and 1, we split this 3, right? We split the 3. Let me write how do we split. We write this as a d square plus 2 plus 1 times d plus 2 equal to 0. So that is d square plus 2d plus 1d plus 2 is equal to 0. We take d common from these two. So by taking d common, d plus 2, and here by taking 1 common, d plus 2, and again by taking d plus 2 common, what we get inside? D plus 1. And by equating this fact, this is a factored form of the given equation. So by equating each factor to 0, we will get d equal to -2 and d equal to -1 as the roots. Right? So these roots are real and unequal. Yes or no? Real and distinct. So for this is just like m1 and m2, right? So we write the complementary function for these roots. Complementary function is the only solution for this homogeneous differential equation. Okay, so we can call it as a y also. So as we are writing the complementary function is what? Hmm? C1 e to the power m1. So minus 2x plus c2 e to the power m2x, that is minus x. Or you can call minus 1 as a m1 and minus 2 as a m2. So you can write that also. That is either c1 e to the power minus x plus c2 e to the power minus 2x. See, order of root is not important here. Is the point clear to everyone? Any doubt, any question?
No, sir.
Hmm? Other people's? I hope the point is clear to everyone. Okay. So this is about the first case, first nature of the root. If the roots are real and unequal, real and distinct. Now the second case is roots are real and repeated or equal, we can say. Okay. So what is the formula for the complementary function? So let me write the formula first. Suppose first two roots are repeated. Out of n roots, see, we have considered already phi of d as a nth degree polynomial. So we are considering n number of roots. This is in general, depending upon the number of roots, we are using that formula. Just like in the last example, the two roots we are getting, therefore we are writing the formula in terms of two roots and the constants only. जितने आपके पास रूट होंगे उतने उसमें आर्बिट्ररी कांस्टेंट्स होंगे. Okay, so suppose if the first two roots are repeated equal, like m1 is equal to m2, and the rest roots are distinct, like m3, m4, and so on, mn. Okay, so with this root we have to write the formula for the complementary function. The complementary function is therefore, so एक बात तो आप हमेशा याद रखो कि जितने आपके पास रूट्स होंगे उतने उसके कॉम्प्लीमेंट्री फंक्शन में आर्बिट्ररी कांस्टेंट्स आने चाहिए. द नंबर ऑफ रूट्स इज इक्वल टू द आर्बिट्ररी कांस्टेंट्स इन्वॉल्व इन द कॉम्प्लीमेंट्री फंक्शन. ठीक है. सो as we have considered here the n number of roots, arbitrary constants must be n in number, right? So I'm going to write the complementary function now for this repeated root. For these equal roots, first I'll write the complementary function of the form c1 plus c2x e to the power either m1 or m2, because both are same. So that is e to the power m1x, suppose, plus, now corresponding to the next third root, corresponding to m3, the next part is c3 e to the power m3x plus c4 e to the power m4x plus, and so on, cn e to the power mnx. Is this clear? This is the formula. Any doubt? Any question in the formula? Now let us see the logic behind this formula. Why we are considering this formula. Okay, so to discuss the explanation, let us consider the linear differential equation of second order, where the both of the roots are repeated. So what will be the factored form? Suppose um, in case of second order LDE, its auxiliary equation phi of d equal to 0 will have how many roots? Hmm? How many roots? It will have two roots, right? It will have two roots. So we consider both of these two roots are repeated. If both roots are repeated, say m1, right? M1 is the root which is repeated. That is d equal to m1 and m1 as a root. So what is the factored form of this phi of d in terms of these two roots? What is the factored form? क्या होगा? Hmm? The two factors will be there, na? Or phi of d can be written as d minus m1 the whole square, or d minus m1 d minus m2. One more thing. I think Sahil have asked in the last lecture that why we are considering the m1 as a root only. Why it is not minus m1? See, m is the notation for the root we have considered. Doesn't matter whether it is plus or minus. If it is minus m, then we will consider here plus m. Okay? D plus m1 and d plus m2. So please don't get confused with this. That uh, this is only the formulas for the factor of this form d minus m1 d minus m2. No. Clear to everyone? Is this point clear? Hello. This is m1. Okay. So this is the factored form of phi of d equal to 0. So what we do, we consider its homogeneous differential equation first. That is d minus m1 into d minus m2 times y equal to 0. And what we do, for the sake of our convenience, for a while, would we consider this to be 0, z. So let this is z. So d minus m1 operated on z equal to 0. Right? So this is again a homogeneous differential equation whose auxiliary equation is d minus m1 equal to 0. So its root is d equal to m1. So for this, how do we write the complementary function? Complementary function is the value of dependent variable involved, right? For the homogeneous differential equation, its solution is nothing but the complementary function. तो solution का होता है dependent variable का value. So z equal to क्या होगा कॉम्प्लीमेंट्री फंक्शन फॉर दिस रूट? इसके लिए क्या कॉम्प्लीमेंट्री फंक्शन होगा, बताओ कोई? हेलो. Corresponding to this, we have the complementary function to be c1 e to the power m1x, isn't it? And if we substitute the value of z here, right, that is already, yeah, what, where z is we have considered to be this, na? So when we consider, actually this is m1, this is m1 here, because sorry, this is m1. So therefore d minus m1 we have considered, m1 into y we have considered to be z, no? So when we substitute the value of z there, d minus m1 d, not z, sorry, d minus m1 times y is equal to z. But what is z? Z is c1 e to the power m1x. If we substitute the value of d, what is d we have considered? D we have considered to be derivative with respect to x. So by taking y inside, it will be of the form dy by dx minus m1y is equal to c1 e to the power m1x. Yes or no? यहां तक सबको क्लियर है? Everyone, please do reply.
Yes, sir.
Everyone,
Yes, sir.
do reply in chat box or by unmuting
Yes,
yourself.
sir.
Great. So And this is the standard form of linear differential equation. This is LDE of first order first degree. Yes or no? First degree, where the solution, हमें पता है linear differential equation of first order first degree का solution क्या होता है? It is of the form, its solution is y into integrating factor is equal to integration of q into integrating factor plus constant of integration, isn't it? So what is p here? P of x क्या है? इसमें p of x is minus m1. What is q of x? Q of x is hmm? क्या है? Q of x is c1 e to the power m1x. Right. So with this, we calculate the integrating factor I is equal to e to the power integration of p dx, that is e to the power integration of minus m1 dx, that is e to the power minus m1x. So we substitute into the solution, we get the solution of this form y into e to the power minus m1x is equal to integration of q. What is q? Q is c1 e to the power m1x, right, into e to the power minus m1x dx plus another constant now, c2. Yes or no? So if we club these two by laws of indices, e to the power 0, that will be 1, right? So integration of c1, but c1 is constant, so integration of dx, c1 times integration of dx plus c2 will be there. So that is c1x plus c2. Is the point clear? So what we are getting now, y into e to the power minus m1x is this. So what will be y then? Y is equal to c1x plus c2 e to the power minus m1x. Clear?
Sir, it will be plus m1x.
Oh, sorry, sorry. Yeah, it is plus. Is it okay now? Is this clear to everyone? Hmm? Everyone, please do reply in chat box the explanation behind the formula. Any doubt, any question? So, in similar manner, this is in case of रूट रिपीटेड चॉइस. अगर रूट 3 बार रिपीट हो रहे हैं तो कैसे लिखेंगे हम? सी वन मोर थिंग I want to ask, I want to tell you that either we can write the formula like this, or see, order of arbitrary constant is not important. So we can write the same thing as a c1 plus c2x e to the power mx or m1x. Okay, right? So that is one and the same, because that is just a matter of arbitrary constants. Hmm? So either your uh, option, if it is MCQ, then either your option will be this or this. So you should know both are one and the same. But actually, anyways, it is your concern whether to write in the second form of the first form. But always remember the logic behind the formula. So in case of repeated root repeated 3 times, if root repeated 3 times, like that is m1 equal to m2 equal to m3, and the rest roots are non-repeated. So m4 m5, and so on, mn. So what will be the complementary function? Yes, what will be the formula for complementary function? कोई बताएगा मुझे complementary function क्या होगा फिर? So in case of root repeated three times, we are going to write the three arbitrary constants like this into the bracket. So how do I write? I'll have to start with c1 x square plus c2 x plus c3 the whole times a to the power m1x, and the rest is for non-repeated root. So non-repeated root के लिए हमें पता है कि कैसे लिखते हैं हम c4 e to the power m4x plus c5 e to the power m5x plus and so on cn e to the power mnx. Is this formula clear to everyone? Is this okay? Hello.
Yes, sir.
Very good. So suppose for example, अगर मेरे पास ऐसे roots है, for example, if the roots are like this, d equal to say 2, 2, 4, 5, like this, then what will be the complementary function? And the complementary function is CF is equal to, hmm? First I'll write the formula for the repeated root. Doesn't matter, huh? Whether you're writing for the repeated or non-repeated first. Doesn't matter. You can write for 4 and 5 first and then for 2 later. So I'm writing here c1x plus c2 times e to the power 2x plus c3 e to the power 4x plus c4 e to the power 5x. We have 4 number of roots. We have 4 number of arbitrary constants. Yes or no?
Yes, sir.
The next nature is if the roots are complex, distinct, complex non-repeated root, or imaginary and non-repeated root. So in this case, suppose suppose we all know that the complex roots are of the form a plus ib, right, or alpha plus I beta, alpha plus I beta, right, where alpha is called the real part and beta is called the imaginary part, right? So uh, there is one standard result in the complex that if a plus ib or alpha plus I beta is root, then its conjugate is also a root automatically. If alpha plus I beta is root, then alpha minus I beta will also be a root, right? So with this, we observed that the complex numbers are always come in pair. ऐसा कभी नहीं होगा कि किसी पॉलिनोमियल को, किसी इक्वेशन को एक ही कॉम्प्लेक्स रूट है. नेवर. Either the roots are in multiples of 2 or there will not be a complex roots. Clear to everyone? So at least 2 is the number for the roots to be complex. Remember, अगर कॉम्प्लेक्स रूट है तो कम से कम वो दो ही होंगे और दो के मल्टीपल में. Clear to everyone? Clear to everyone? Complex numbers are always, or complex roots are always come in pair, come in pair. So let me ask you that if we have a cubic equation, then is it possible to have all its roots to be complex? For the cubic equation, is it possible to have all its roots to be complex? Let me see how many of you are replying. You can reply in chat box. Ankita says no. Harsh says no. Mihir says no. Remaining peoples, बाकी के लोग क्या कहते हैं? For the cubic equation, is it possible to have all its roots to be complex? That is my question. Hmm? Maybe one real and two complex. Very good. No. So Prathamesh have given the explanation. That is okay. I hope the point is clear that all its roots are not complex. That is not possible. But all roots can be real. That is possible. And if there is one complex root, then its conjugate will come. So at least two roots to be complex there. So the rest root must be real. Clear to everyone? Kunal says 1 omega omega square. That is a complex. That these are the cube roots of unity. 1 के roots है ये. Right? 1 के 3 roots है. Anyways, I hope the point is clear to everyone that for the odd degree equation, uh, it is not possible to have all its roots to be complex. But in case of even degree, there is a possibility to have all its roots to be complex. Okay, so for this complex root alpha plus I beta, its conjugate is also root, that is alpha minus I beta. So totally we are considering here the two different root, alpha plus I beta and alpha minus I beta. So its complementary function must involves two arbitrary constants. So let us see the proof directly that here m1, what is m1? M1 is say alpha plus I beta, m2 is alpha minus I beta. So with these two roots, we know the formula for the complementary function CF is equal to क्या होता है C1 e to the power m1x plus C2 e to the power m2x, right? So when we substitute m1 and m2 here, that is C1 e to the power m1. m1 क्या होता है? m1 is alpha plus I beta times x plus C2 e to the power m2. m2 is alpha minus I beta times x, right? So that can be written as C1 e to the power alpha x e to the power I beta x plus C2 e to the power alpha x um, e to the power minus I beta x, right? So what we do, we write the formula. See, first of all, we can take e to the power alpha x common from both of these, right? So I'm taking common e to the power alpha x. Inside it will be e to c1 e to the power I beta. But do you know the Euler's formula that e to the power I theta को मैं कैसे लिख सकता हूँ? It is equal to cos theta plus I sin theta. Do you know this? This is called Euler's
Yes, sir.
formula. So I can write exponential function in terms of cos and sine. So we use this relation here that e to the power I into this theta beta x is a theta, and here also minus beta x. So what we do, and here also we have one more e raised to minus I theta क्या होता है, that is cos theta minus I sine theta, right? So these two formulas we are using here. See here, Aditya Patil have joined now. It's time to stop, and he have joined. Yes, Aditya? Aditya Patil. Aditya Patil, can you hear me?
Yes, sir.
Why you have joined late?
Sir, I joined now.
Why? That is what I'm asking.
Sir, I had some issues.
Issues. But remember the time, okay? This is not.
Yes, sir.
Oh, anyways, so if we use the Euler's formula here, C1 e to the power I beta x को कैसे लिखूंगा मैं? I can write it as a cos theta. Theta is beta x plus I sine theta, that is beta x, right? Plus C2 again e raised to minus I beta x को कैसे लिखूंगा मैं? Cos theta, that is beta x, minus I sine theta, that is beta x. Is it clear? Any doubt, any question for this? So what we do, we combine the terms, that is e to the power alpha x into, uh, if I take cos beta common from both of these, then c1 plus c2 times cos beta x, hmm, plus I c1 minus I c2 times sine beta x. ठीक है? And these are constants. This is constant, this is constant, so we call it as a another constant, say a cos beta x plus b sin beta x. Okay, so I'm writing here e to the power alpha x into a cos beta x plus b sin beta x. This is in bracket. So this is the formula for the complementary function in case of complex distinct root. Is this clear? Any doubt? Question? Clear to everyone? The formula for the complementary function in case of complex distinct roots. Hello? Now, in case of complex repeated root, that is the fourth nature, if roots are complex repeated. Suppose if alpha plus I beta repeated twice. So its conjugate will also repeat twice, right? So how many roots totally will have then? We will have
4.
four roots. So we should have four arbitrary constants into its complementary function, right? So I'm directly writing the formula now. The logic behind the formula is the same as we have discussed in the second case. So CF is equal to e to the power alpha x into c1x plus c2 times cos beta x plus c3x plus c4 times sine beta x. Is it clear? Clear to everyone? Where alpha is real part and beta is the imaginary part. For example, if we solve this, solve d square plus 2d plus 5 times y equal to 0. Then you please check what are the roots of this. D square plus 2d plus 5, the auxiliary equation, equal to 0. So what are the roots here? D equal to minus b plus minus square root of b square minus 4ac upon 2a. So that is minus 2 plus minus square root of minus 16 upon 2a. That is minus 2 plus minus 4i upon 2. So what are the roots? Minus 1 plus minus 2i. Yes or no? So what is alpha here? Here alpha is minus 1 and beta is 2. ठीक है? Beta is the coefficient of I. Remember, most of the students are confused with beta. They are considering along with I. No. I के साथ जो होता है, that is your beta, imaginary part. So what will the complementary function therefore? CF is equal to e to the power alpha x, that is minus x. X is independent variable, remember. So it again changes according to the given equation. So e raised to minus x c1 cos beta x. What is beta? 2x plus c2 sine beta x. This is your required complementary function. Is this clear to everyone? Hello? Everyone, please do reply in chat box. These are all the 4 cases for the complementary function, and this is all about the complementary function. That's it. इसके बाहर कुछ भी नहीं पूछेंगे regarding the complementary function. If it's clear to you, definitely you'll get full marks for the complementary function.